Hello everyone. Today we're going to be talking about how to apply all these nifty features about polynomials that we've been talking about. So you're going to learn how to apply distributing polynomials as well as how to apply factoring polynomials. So our first example is about a football field. So it says find the area of a rectangular football field with a length of 3x minus 2 and a width of x plus 1. So let's get started. This is going to be actually an application of distributing polynomials. So if you think back to when we distributed, it's basically going to be a little review of that after we set up our expression. So let's get started. Okay, so again, I have the problem on here. I have my nifty little football field. So we're trying to find the area of this rectangular football field, okay, which it's always helpful if you can draw a picture to kind of visualize what's going on. Okay, we know the length of the rectangle is 3x minus 2, which honestly, you guys, it doesn't matter which side of the field you call the length and which one you call the width. It's kind of all about the perspective. Okay, so it really doesn't matter what I call what. I'm just going to call the length this. So these are the lengths of my football field, okay, which I'm just going to label one of them. So the length is equal to, which that's a cursive L, by the way. Usually we use a cursive L, lowercase l, for the length because we're fancy like that. You got to use your fancy hands. Okay, so the length is going to be 3x minus 2. The length of the football field is 3x minus 2. Okay, and then we also know the width of the football field is x plus 1. So the width of the football field is x plus 1. So if these two sides I'm going to call the length, then the width would be the other two sides, which again, it really doesn't matter which you call the length and which side you call the width. Okay, so my width is x plus 1. Okay, and then the goal is to find the area of this rectangular football field. Okay, which if you didn't know, the way that you find the area of a rectangle is by multiplying the length to the width. Okay, so let's set up our problem. So we know area, big A is area. So area equals the length, which the length is 3x minus 2, times the width, which the width is x plus 1. All right, so I substituted in the values into my formula for the length and for the width. Okay, and then after that, I have a parenthesis times a parenthesis. How do you solve a polynomial when you have two parentheses side by side? You would distribute this thing. So we're going to be distributing the two parentheses, and that will give us the area of the football field, which since we don't know the value of x, I can't actually solve for the actual area of the football field, but we'll at least have an equation so when you do find out what x is, then you'll know the actual area of the football field, which will be really cool. Okay, so I'm going to rewrite it again just because I kind of drew in these little arrows. It'll get a little busy if I try to distribute with how it currently looks. So I'm just going to rewrite it. You don't have to, though. Okay, well, let's start distributing. So we're going to start with the first term and distribute or multiply it to both terms in the second parenthesis. So we're going to have area equals 3x times x. Well, don't forget, if you do not see an exponent, there's secretly a 1 in the exponent. Also, if you don't see a coefficient or the number in front of the x, there's secretly a 1 in front. So I'm going to multiply the two numbers, or the coefficients. So 3 times 1 is 3. And then how do you deal with exponents on variables when you multiply the variables? You do add the exponent. So 1 plus 1 is 2. So this will be 3x squared. All right, and then 3 times 1 is a positive 3, so plus 3. And then I don't have anything to multiply the x to my second term. So I'm just going to bring on down that x. Okay, and then I'm just going to do the same thing just in my second parenthesis. So I'm going to distribute this negative 2 to both terms. Okay, so negative 2 times 1x, well, negative 2 times 1 is negative 2. I don't have anything to multiply to my x, so I'm just going to bring it on down. And then negative 2 times 1 is negative 2. And then after this, you guys, all we're going to do is combine like terms, which I'm going to start with my highest exponent. Which term contains the highest exponent? It would be the 3x squared. And I don't have any other x squared terms, so I'm just going to bring that one on down. Okay? My next highest exponent is x to the first power, which I have two terms that have x to the first, 3x and negative 2x, which don't forget, when you add or subtract like terms, you don't touch the exponents. You only add or subtract the coefficients or the numbers of the x. So 3 minus 2 is 1, and then I just leave the x alone. Don't touch the x, or that's when the demon cats will get you. So I'm not going to touch x, and 3 minus 2 is 1. So I could write 1x or just plain old x, whatever floats your boat. And then my final term is the negative 2, and I don't have any other terms without the x. So I'm just going to bring that one on down. Guys, so this is our area of the football field. I know that it doesn't really help us to know like the actual area since we don't know x, but if you knew x, then you could easily find the area of this lovely football field. All right, so you have learned how to apply distributing polynomials, which is pretty awesome. Excellent work, everyone.